be described as a transformation of h of x equals x minus 2 squared plus 3. Okay, so I'm changing this function or this question up a little bit because I know the question on the test is a little more like this one. All right, so the first thing I'm going to do is I'm going to look at which one is the new function and which one is the old function. So it says as a transformation of this function. So this tells me that I'm going to start with this function and it's going to move to this function. So I'm going to do that two ways. I'm going to show you one algebraically and two graphically, because one of these two ways is going to show up on your test. So algebraically, I'm going to compare h of x equals x minus 2 squared plus 3 and see how that compares to g of x equals x plus 4 squared minus 2. All right, to see that, first thing I'm going to do here is I'm going to identify that h, comma k, h is 2, k is 3. A is 1 in both, so we don't need to worry about how a has changed, but you do want to look and make sure that a is the same value. All right, and now in the new function, h, comma k, is, be careful of your sign again, this is negative 4 and negative 2. So your vertex was at the point 2, comma 3, 2, comma 3, and now your vertex is at negative 4, comma negative 2. So algebraically what has happened is the change in y, right, we've gone down 5 units. The change in x, right, from 3 to negative 2 is 5, has gone down 6 units. So this graph has shifted down 5 units and left 6 units. And that's an algebraic comparison. Now, let's look at graphically. If we were to graph our original function, h of x, again, we're starting with h of x. H of x is located at 2, comma 3. 2, comma 3. And there's been no scaling, so it would look something like this. G of x is located at negative 4, negative 2. Again, no scaling, so it would look something like this. So if I were to move from this graph, remember this is h of x, to this graph, g of x, I would have to move left 1, 2, 3, 4, 5 units, or sorry, 6 units, and down 1, 2, 3, 4, 5 units. So I move left 6 and down 5. That means h, comma k was negative 6, comma negative 5. So I would move left 6, down 5. Now I hope that you could even compare these two with one another. Oh, sorry, I went off my video there. So again, it would shift left 6 units, down 5 units. So you need to be able to do this either algebraically or graphically. That question will be on the test. All right, let's take a look at the next question, number 12. Number 12 says the equation y equals x squared minus 4x minus 5 represents a parabola. Find the vertex and axis of symmetry. All right, so to find the vertex, we identify A, B, and C. And then we're going to use x equals negative b over 2a. And then we will substitute into your original equation. And this will give me h and the axis of symmetry. This will give me k. So let's do it. So our equation is y equals x squared minus 4x minus 5. So here's a, b, c. So a is 1, b is negative 4, and c is negative 5. I'll go ahead and sub it into my equation. All right, my equation is x equals negative b over 2a, and b was negative 4, a was 1. This will become positive 4 over 2, which is 2. So my axis of symmetry is right here at x equals 2. Now to find the vertex, I need the y coordinate, or k, so I'll sub it back into y equals x squared minus 4x minus 5. And I'm subbing in my value of 2. That gives me 4 minus 8 minus 5, which is negative 4 minus 5, which is negative 9. And so my vertex is 2, comma, negative 9. H, comma, k. All right, moving along, let's look at number 13. All right, so number 13, I think I'll have enough room to write over here. First thing that I want to read is what it says, which inequality is shown in the graph. And then I want you to notice each of these are the same equations with the exception of their inequality symbols. So the only thing I really need to focus on here is the inequality symbol. All right, so first of all, if you have a less than or a greater than with no equal to, these will be dashed. If you have a less than equal to or a greater than equal to, these will be solid. So let's take a look at our graph, and it might be a little hard to see, but this curve is indeed dashed. That tells me right away that I can get rid of these two. So I'm going to cross off A and C immediately. And then we're going to think about the steering wheel, right? So on the steering wheel, we have the turn signal. Now, if we're turning to the right, so we're going to go this way. If we're turning to the right, you notice that's this inequality, then we will click our signal upward. So that means we will shade above the vertex. So on both of these would be above the vertex. However, if we're turning the opposite direction, so now we're going to turn to the left, right, we're going to turn to the left, which would be, I'm going to go all the way back around so you can see it, a less than symbol, right, which means these two, we would hit our turn signal downward. And so we would shade on these two, we would shade below the vertex. So anytime you have a less than or you're turning left, you're going to go downward below the vertex. Anytime you're turning right, you're going to go above the vertex. So that means that I can get rid of these two, right, the less thans, which I've already gotten rid of one of them. And the only possibility is that it's a greater than, because we're shaded above the vertex and it's a dashed line. All right. So similarly, you see right here, it's a greater than. So we have a dashed inequality, a dashed parabola, and it's going to be above, and it is above the vertex. But it does say which point is a solution. Which point is a solution to? So a solution means that algebraically, a solution will make the equation or inequality true. So rather than memorizing, oh, it's a solution if it's in the shaded area, I'm going to show you how to verify using the equation or the inequality. So our inequality is y is greater than x squared plus x minus 6. So we're going to do method 1 first, which is algebraically. We're going to verify if these points are indeed solutions. If I substitute in, remember this is x and this is y. If I substitute in 0 for y and 2 for x, I want to know, is this a true statement? 0 is greater than 4 plus 2 minus 6. 0 is greater than 0? No. This is not a true statement, so this is not a solution. Now I'm going to compare that to graphically. So graphically, what has to be happening? So I did eliminate, right? This was my x and y. I substituted them in. Graphically, what needs to be happening is that a solution falls in the shaded area or on a solid line/curve. So if we were to investigate where this point falls on the graph, 2, 0, 2, 0 is right here. It's on the dashed line, which verifies, being on the dash, right, that this does not work because 0 is not greater than 0, or it's not a solution if it's on a dashed line. However, look how this problem would have changed if this were an equal to. If this were an equal to, this would have been a solid line, which means that I would have had this going all the way down. 0 is greater than or equal to 0 now changes my answer to yes, 0 is equal to 0. Okay, but it's not, right? There's no equal to, so it's still a no. Okay, now let's go ahead and verify. We're going to do this algebraically and graphically. 0, negative 6, here's graphically. It's on the dashed line, so I'm going to say no. However, if I substitute this value, right, for x and y into my inequality, remember there's no equal to, so it'd be y is greater than x squared plus x minus 6. I'm going to substitute in x is 0 and y is negative 6. Negative 6, is this greater than, this will go away, negative 6? No. And so we can see why those both are untrue statements. Let's go ahead and look at C. C is at negative 2, 0. Already I see it's in the shaded area, so it is a solution, but we're going to check it algebraically one last time. Again, x, y. 0 is greater than negative 2 squared plus negative 2 minus 6. And let's see what we get. So 0 is greater than 4 minus 2 minus 6. 0 is greater than, that would be positive 2 minus 6. 0 is greater than negative 4. Yes, that is a true statement. 0 is greater than negative 4. Now, there may be more than one solution, so you should always check the last one. 6, 0 would be way over there. That is not a true statement. All right, the last one, number 15. Writing this equation in vertex form. Step 1, identify A, H, and K. Step 2, use x equals negative b over 2a. Step 3, sub into your equation your solution. And step 4, write in y equals ax minus h squared plus k. All right, so our equation is y equals 2x squared plus 4x minus 3. So a equals 2, b equals 4, c equals negative 3. We're going to sub that into x equals negative b over 2a. b is 4, and a is 2. Negative 4 over 4, which is negative 1. So h is negative 1. Then we're going to sub that value, watching our signs, right, back into our equation. Y equals 2x squared plus 4x minus 3. Most common error I see is just algebra right here. Square it first, then multiply it. So we get that's 2 times 1. That'd be minus 4 minus 3. Negative 2 minus 3, which is negative 5. And we're going to write it as, this was my k, a, so y equals a was 2, x minus h minus negative 1 squared plus k. K is negative 5. So we have y equals 2, x plus 1 squared minus 5. And that is vertex form. All right, guys, that's the entire video. I will see you tomorrow in class. Have a good evening.